Hi, everybody. I'm sorry for all the delays and everything, but we are now finally started, thankfully. So myself, I'm Jason Rock. I work at Silicon Labs. Start us out here? Yep, so I work at Silicon Labs. As I just talked to one of the gentlemen here a little bit earlier, we are a company that actually just hit our 20th year. So we originally were a startup coming out of, many people came out of the Crystal semiconductor division as they were getting acquired by Cirrus Logic, and originally we were about mixed signal integrated products, and you know, the way things kind of advance, we now have about half our R&D and pretty sizable amount of investment in IoT. So it's kind of nice to see the fact, as Dave just mentioned, this group has grown to about 2,000 people. So it definitely shows you how just kind of the momentum of where, you know, originally it was from PCs, then it's to mobile, and now it's moving into the things that connect to the mobile and everything else in connected home. So it's, you guys are in the right market to be in, to be focusing on IoT. And it's hopefully something that still allows, we're doing something to work for you guys for that. Within our product line, we've, you know, specifically for IoT, we've got things like MCUs, wireless, Bluetooth, Zigbee, the new upcoming standard Thread, which basically puts an IP number on every individual item out there in the Internet of Things, and then sub-gig and some of the other things like Wi-Fi is one of the new things that we have. You know, the last thing I'll say too is it's kind of nice to be in a meetup where you actually can drink. It makes my life a lot easier. I don't have to really work very hard for this. So I'm representing the Silicon Labs. You're going to understand here in a little bit why hardware alone can't just get this done. You need software too, and a great company for that is Neutral Mobile.
Thanks, Jason. So my name is Thaddeus. I'm representing the company I work for tonight, Neutral Mobile. We are an emerging tech agency here in town. That's kind of marketing speak for we build really cool stuff. So some of the recent work that we've done, we're actually helping a company called AgCo get agriculture connected to the internet. So the goal here is to really make it easy to monitor and track the current status of agricultural equipment. And so we've been focused on that. One of the projects near and dear to my heart is called Beam. It's a beautiful HomeKit app for iOS. And then you've probably heard about Under Armour Record. It's a new connected fitness platform, and we had a really big part in doing that. So these are just a small sample of some of the IoT and kind of connected devices work that we've done recently. We've got a lot more things that we're excited to get started on too.
So, you know, I don't know if you know much about Under Armour, but they were like this little small group here in Austin, and it's just exploded into, if you've been in the downtown area, they've got a pretty sizable office now. It's showing you how IoT is proliferating, and it's proliferating here in Austin. A company that even Silicon Labs worked with is guys like Sabertron and even Atlas Wearable, which actually was the first time when I came here to an Austin IoT meetup. I want to talk a little bit about challenges with IoT, because I think that's one thing that we all kind of struggle with when we get into new projects like this. This is a true story. So about a year ago, our VP of Sales came to our division and said, okay, so one of the other things like Silicon Labs did was we acquired a company named Blue Giga, which provides BLE modules, Bluetooth modules. And it's supposed to make things a lot simpler for people to integrate Bluetooth and connected cloud into their products. Well, he had a situation where there was a pretty big opportunity for a connected snowblower. And so they tried, and this is kind of a brand new company, Blue Giga, that we just acquired, and they tried to basically present, how am I going to present, if you're going to take a Bluetooth module into a snowblower, you're going to get to the cloud. And as far-fetched as that sounds, that's actually happening now. DeWalt just recently announced that they've made BLE connected battery packs. So they can, from your phone, enable, disable the battery. You can monitor time usage. If you leave it off on a job site, I mean, these things, if you bought a DeWalt battery, those things are like 40 bucks a pop. You kind of want to know where those are at, and you can use the Bluetooth proximity detection to figure out when you've walked away from it. So there's actually nice applications with this. So we were presented with this challenge. How do we deliver a message, deliver a reference design, deliver solutions that can support basically a snowblower taking a BLE module in, and people can visualize how it's going to help them by getting it up to the cloud. So within that, there kind of presents challenges, and that's kind of why there's two companies here today, because the reality is this stuff is really hard to do. And like for myself personally, when I started my career, I was a hardware engineer. So I'm now a systems engineer, and hardware, which we'll kind of talk about here in a little bit, is a challenge in and of itself. And honestly, one of the things I'll actually say is, and we'll talk about the next bullet here in a way where maybe a show of hands here. So what we're going to do here is you're going to raise your hand, and if you want to raise and hold your hand to the next comment, and if you're still in that kind of camp, hold your hand up. If you're not, kind of put your hand down, and then we get to the next camp, you can put it back up if you're doing this kind of stuff. So if you've actually done somewhat of a production-worthy or production-worthy hardware, raise your hand. Now, have you ever written any kind of firmware with hardware? Raise your hand. Okay, now how have you worked with iOS apps? All right, who has deployed a production-worthy cloud? That's the problem. I only saw maybe like 1 or 2 hands that has done everything. And if you have done everything, I kind of question why you're here. You should be a billionaire by now, selling right up against Elon Musk. I mean, seriously, because if you have all these talents, you're unique. Because honestly, Sabertron, the snowblower guy, Atlas wearable guys, when they presented too, they started with multiple little boards, trying to iterate, and then eventually get their stuff into the cloud. This stuff is not easy to do, and we need to find ways to fix these challenges. Because not only is it hardware, but it's also the software side. You can't provide a complete solution with this stuff.
Yeah, so not being the hardware representative here, this list is daunting. I do have experience coming from a firmware background, but that's very different, as most of you know, than the electrical part and the stuff that Silicon Labs is especially good at. So all of these things actually seem really easy from my standpoint, because the Silicon Labs team did an incredible job putting that all together. But the next set of challenges then are, well, how do we do mobile apps? Mutual Mobile comes in at this point, because these are the things that we're really good at. But even though we're really good at these, there's still a lot of questions.
Would you read them out?
Yes, absolutely, I will. So the first challenge for building an iOS app, I'm an iOS software developer. Should we use Objective-C or should we use Swift? Swift is a risk because it's still changing. It's not like C++. Well, that's a bad example too, because it's changing. The Android folks, yeah, we've got Java, but we've now started a conversation where we have 2 implementations of the same app. Is that really the route that we want to go? We've got to make that conscious decision, because we're going to support 2 platforms. Do we need to support other platforms? Are there other players that are, worth keeping an eye on? How are other platforms like maybe the Raspberry Pi going to factor into this? So all these types of questions are things that we have to wrestle with. How do we do Bluetooth support? We've got really great APIs on iOS. They're trickier on Android if you've done that. And we've got a good contingency of Android developers here that you can pick their brains after this. But then questions like, what do we do about location-based services, iBeacon, Eddystone? Which of those makes sense on each of those platforms? We haven't even talked about screen sizes and actually just making this thing look good on all the different phones. And we used to tease the Android folks that this was a problem, and it's getting pretty bad on iOS too. What versions of the OS are we going to support? Are we going to do tablets, rich tablets, all that sort of thing? So there's a bunch of different challenges that we have to face. We still haven't talked about the cloud. And this is really I think one of the trickiest parts for some of the goals that Jason and his team set out for us is, we want to have a system that is real time, that we can actually see live data, and has this kind of really great experience, but that can also then contain a lot of data and be retrievable after the fact. So we have to address, well, what functional requirements do we have? The very next thing, and probably actually the first thing for a lot of people, is, well, how much is this going to cost? And what kind of maintenance is going to be required? We really don't feel like being an IT staff. We really don't want to have to, maintain a server, wrestle with Docker images, all that kind of stuff. Like, if we don't have to, it'd be great if we didn't. So what platforms are available? What choices do we have? Do we want to go, kind of sort of bare metal on AWS, where we're actually administering a Linux machine or something like that? We use a platform like Parse. When we started this project, Parse was still a viable option. If you followed mobile, that's maybe not a good bet at this point. But then there's Firebase from Google or Azure from Microsoft. Those are really just kind of the big four. There's lots of other smaller players we could do, smaller VMs, all that sort of thing. So how do we make sense of this? And this is where I think the combination of these two teams working really shines. So.
And I apologize, I didn't realize how small the screen is for the back here. So I'll go through the hardware really quickly here. So cost, prototypes, this stuff will just add up really quickly. RF performance, if you've done wireless design, good for you, you're an expert, and now all of a sudden your skills are very relevant recently because IoT has a lot of antennas on it. But if you haven't, you have to worry about things like Gaussian patterns, which about 3 years ago I didn't quite know that, even though I worked at wireless infrastructure. That is kind of a big deal on a little wearable. You gotta have a good pattern that doesn't have gaps in it. Battery performance. So before, when I first started, it was like wireless infrastructure, 30-layer boards, high speed. This is really tough stuff. Now it's how do you do everything in a small 2-layer board that's going to be miniaturized on a coin cell battery. And that's really challenging because you got to be able to be really reliable connection, but just reliable enough, because if you're sending too many messages out, you're burning the heck out of that battery. And so that's a lot of little interesting challenges that you got to do, and you're just going to eat up your budget very fast if you don't have a good starting point with this. So that kind of gets us back to the challenges here. So we needed to come up with a way that it shouldn't be where we have to go to 2 different companies just to get started with a platform. So what we wanted to do was satisfy that original challenge, was how can I make a snowblower guy see that they should use a Bluetooth module, and while they do that, they can visualize what they can get out of a cloud. Well, the answer is I can't drag a snowblower to that guy, like hack one up and let him actually see exactly what he's going to get. It's too big. I can't fit it on in an overhead compartment in an airplane. So, but we did need a vehicle, and that's kind of the euphemism here. We did need a vehicle that we can hand to our sales guys. We can present it to a lot of different people. It has to be low cost so that many people can interact with it. We needed kind of a little vehicle that people actually are very familiar with, that they can actually kind of get this message. So we ended up choosing a Pinewood Derby card. So how many of you guys actually were in Cub Scouts, Boy Scouts, maybe had a brother in Boy Scouts? Jenna, I know you did. It's a very recognizable thing. And so when we first pitched this idea, actually a company kind of pitched this to us, and we're like, and then eventually we start talking about those good feelings, or that, oh man, my car was last, or something like that, But it actually is kind of a very recognizable thing. So you kind of get past the actual product and get into the discussion of, well, how do I take this product, connect it with sensors and Bluetooth, and now start talking about the cloud. So this ended up being the choice vehicle that we used for this. So this is what we call ThunderBoard-React. Because originally we had like a Thunderbird shell with this, and then we were kind of worried about trademarks and everything, so we had to kind of call it ThunderBoard. So that's kind of the euphemism of this.
Hasn't it been 20 years though?
For what, Thunderbird?
Yeah.
I think didn't they release like a new version of that car? And
They still got Mickey Mouse.
Yeah. Well, and then the honest thing too, the gentleman, was it Bob or John?
Bob.
So my wife is actually a patent attorney too, and she'll say with trademarks, as long as they're kept live, which I imagine the people that make the Thunderbird, they probably kept those live. Yeah, Ford, yeah. So it doesn't cost that much to keep those maintained. Anyways, so what we're trying to do here, which is basically under the hood of this, and we'll kind of show you this, is under the hood, it's a small, very cheap sensor board with a Bluetooth module. It has sensors, so like environment. You can kind of, from the view you get in the front, you can read the sensors, but it's basically temperature, humidity, ambient light, UV, and even motion with a Hall effect sensor that we can sense with this. And we also have an accelerometer, so we can detect motion, and then some buttons and I/O because we're all engineers and we like to play with buttons and I/O. Yeah, let's do the demo. So we're gonna switch over. So since the other thing we kind of made this too is like for our sales guys, if they have to, Bluetooth, especially for Silicon Labs, I'll be very honest, we're really new to the market with Bluetooth, so we had to find a way to hopscotch and get our guys to get their foot in the door. So this is the other reason why we made it this kind of small little demo so that they can do lobby pitches. So if they can't even get past the lobby, they should be able to present it without a projector. So we're having to kind of present this mobile app here this way.
All right, so if you didn't see that, I apologize for the folks in the back. We actually went through the discovery process. So I've got a phone here. I've got a phone that's connected and projecting up here, but it is actually connected via Bluetooth to this car. And so we've got 3 demos here that we've kind of put together. Start with the environment demo. It's the easiest to grab a hold of quickly. And this demonstrates 4 of the sensors that are on the board. So you'll see here temperature, humidity, ambient light, and then UV index. So as you take the shell off the car, the ambient light goes up. And then if you cover it up, obviously the ambient light increases. It's a comfortable 73 degrees Fahrenheit in here. So fairly straightforward. The second demo is where the software guys start to get excited because we can actually affect change on a physical device. And so Jason is actually holding the switches here, and you see these cool animations happening as he's pressing them and then letting go. And then if I touch these 2 buttons, there's a green and a blue LED on the ThunderBoard-React, and those obviously map directly to the buttons that we have here in the iPhone app. So we skipped over it at the bottom. There's this connected bar too. It gives you some information about the name of the board, the battery level, and then the current firmware version. Now if I jump back out, the kind of the premier demo here is this motion demo. And so if I tap on that, here you see kind of a basic representation. This is actually a 3D model of the ThunderBoard itself. And so this is interesting for folks that maybe are doing that elevator pitch. They don't have the whole kit with them. You can see on the right side there's orientation and acceleration data, and then Jason's spinning the wheel so that Hall effect sensor is actually reading numbers and calculating speed. Given the diameter, you can figure those things out. I'm going to jump out though real quick since we're in kind of a premiere situation. We actually have the car model, so I'm going to switch the settings to the car model, and we actually get a nice 3D model of Pinewood Derby car here instead. So you can see as he moves the car around, it actually moves in the 3-dimensional space. And we've added a couple of additional bits of data here. So there's actually speed and total distance. So we've got a track. I think there's a track at the Silicon Labs office, but we've got a track at the Mutual Mobile office too. And you'll get to see a little sneak peek of that here at the end. But you can actually run these cars down the track and get good numbers on distance and their speed in real time.
Pretty sweet.
So the next thing that I want to show while we're doing this, I'm going to go ahead and turn on this switch at the top. This is now streaming, and so with just that touch of the switch, we're now streaming this data to the cloud. I'm going to jump out. We've got just a standard share sheet here. So I could actually share a URL with any one of my contacts. I could send an email, or I could just open the URL in Safari. And that's going to pop open Safari browser. And what you're going to see here is, here's some graphs, and assuming the Wi-Fi holds out, these graphs are actually updating in real time. So as Jason moves the car, you see these updating, which is pretty neat to think about for a second, that this car is actually streaming data through the iPhone up to our online database, and then delivering that back down in real time. So what's really great is, thank you. Those demos then, in addition to the real-time component, that URL is unique for this session specifically. So I can later on go in and share that URL. That data is still preserved. It's still in the database. I can share that if I have a really good engagement with a potential client. I can demonstrate that. Or most of us are more interested in how do I actually build a product out of this. A great example of here's some data that I've collected over the course of a month from a weather station that I decided to build or something like that. So a lot of really cool materials here that are ready to build awesome stuff. I'll get into that. So we'll switch back to the slides here. I'm going to hand it back to Jason. He'll kind of give you a little bit more in-depth look at the hardware that's on Thunderboard.
All right, so to get a little more tech specs, because we like to talk a little bit about the technology within this. So, like I said, if you're a wireless expert, by all means, put down the chip, and build up the antenna, maybe an inverted F or something like that. If you got that skills, go for it. But if you're a little bit, I just want to get a good prototype up and running, Bluetooth module is the way to go. Wireless modules are really nice because, for example, like a company like us, we certify these FCC. So in theory, if you don't muck with it, you can pass on the FCC certification if that's the only thing that you're changing or adding within this project. It handles the antenna. You get also a base level of stack firmware with it. So instead of having to build everything from scratch, you're already building something that you can basically pull different plugins. So if you need proximity, for distance between the unit and the Bluetooth, your phone, you can basically pull that in without a lot of firmware writing of your own. There's a lot of things you can gain by starting with a Bluetooth module. And if you're like a guy that's actually going to go compete with Atlas Wearable or the Apple Watch and everything, you come up with this great idea for a wearable. Even just starting out with a Bluetooth module, something like this, it's not that hard to then port down into a chip-specific type project and being able to get to the cost levels that you're going to need to get to. So Bluetooth modules are definitely a way to kind of rapidly get a nice prototype. Now sensors. Now the one thing that's interesting, as I've kind of progressed in my own career, sensors have always been these very analog, specific type, finicky, very difficult type parts. And if you definitely want to have a lot of expertise in them, because even just like messing with an ambient light sensor, if you get the ambient light sensor off the skew a little too much, it's going to oversaturate the sensor and just completely blow up your numbers, just making you think you're at UV 155, which actually happened in our lab here, as opposed to like UV2 or something with just a normal cloudy day here in Texas. So the nice thing about like sensors now is many of them have a mixed signal component where they're actually digitizing a lot of things that you would have had to do on your own. And so sensors that we have, like the 1133, which is an ambient light and a UV sensor, the 7021, which is a relative humidity and temperature sensor, which is kind of unique to have that all in one package. All of these have a very standard I2C interface. So you can write very basic firmware to either bit bang it or write some sort of driver specific type I2C firmware to enable these things and read from them. The other one just recently that we've added is a Hall effect sensor. So this is that magnet sensing in the wheel. It's a little bit big to be using a reed switch to do magnet sensing in a wheel. So we actually making use of this Hall effect, which is the SOT23. So it's something that you can do either for positioning or like a door sensor and things like that. And then beyond that, we also had the accelerometer. So I think the two big guys in accelerometers are InvenSense and Bosch. This particular one, we picked the 6-axis Bosch because they had a nice, really good firmware driver, and we were basically immediately able to pull this into our code. Just took a couple days, and we had a lot of the sensor readings from it. But I have to admit, of all these sensors, the accelerometer was probably the most difficult because trying to render that 3D model, we actually had to worry about relative positioning with that. And if you actually, and we'll kind of talk about this in the software, but you can move it fast enough where you kind of get off the skew and you have to calibrate it and everything. And then the other thing too, this gets back into the coin cell battery kind of thing. This is definitely an area where accelerometers do much better with lithium polymer batteries, so the LiPo batteries that you see in wearables that you recharge, than they are coin cells. Coin cells have a higher internal resistance within them. So out of all these sensors, this is kind of the one that was a little more of a challenge with a coin cell battery, but it's able to last, I think, like a month and a half when it's able to kind of go into sleep and everything. with this thing.
So that's kind of the overview of hardware. Then if we switch over now to software, obviously we're using Bluetooth low energy here. For the most part, most of the services and characteristics that are exposed by Thunderboard are standard GATT services. So if you're familiar with the Bluetooth spec, there are already predefined service identifiers and then characteristics associated with those services. So except for the places where they didn't exist, we use the standards. And then there are a few additions that we've made that are using unique identifiers. For the places that make sense, we're actually pulling the data, and then the places where it doesn't make sense, we use notifications, another standard feature of GATT servers. And then the board, we haven't talked about it much, but the board also supports beacons. So in that decision between beacons and Eddystone, we went with beacons, mostly for the benefit of the iOS folks because it was much easier and much better platform integration. So we didn't show it, but the way the notifications actually work, if you have opted into a specific device, then when you're near it and your screen comes on your phone, you can actually be notified that that board is nearby. Swipe and immediately connect to that device and start at that demo screen versus the device selection screen, so you can bypass that whole step. It seems like maybe sort of a silly thing until you're in an office where there are 20 or 30 of these things and the QA team is going nuts. It's really nice to be able to, single out that one board that's always on my desk. So you can actually establish a relationship with just one device and know that, okay, this is actually the one that I want. So it turned out to be a really handy feature. And again, the things that we're showing here, I happen to be biased towards iOS, but all of this stuff works on Android too. So the environment demo, y'all got to see that in action. This is one of the places where we actually pull these characteristics. So there's just a timer in the mobile app that fires. I think it's every 3 seconds, so that you still have that feeling of, pretty real time, but we don't need to collect the data. We don't need to be steady streaming. These things don't change that rapidly, unless you're the QA folks and you put them in freezers and then ovens and things like that. But this is in terms of power usage, this is a really low power demo. So you can run a long time running this demo. And then here we also honor users' preferences in terms of measurement units. So we'll convert to Celsius. We established a policy early on that's important in software to determine what your units are and then convert at the very last minute before the user sees them. So this device works in Celsius, and so we use Celsius everywhere internally. And it's only right before it appears on the screen that we decide it's time to go to Fahrenheit, if that's the case. The I/O demo, these characteristics obviously notify, and so anytime there's a state change, high or low on those switches, the GATT server on the Thunderboard sends a notification letting the mobile app know that that value has changed and we can read that. These devices, if you're not familiar with how the digital characteristic works on the GATT services, these are actually masked, so there's a whole bunch of IOs connected together, and then you have to do a little bit of bit math to figure out, okay, well, which one's high, which pin is low. And so that's, that's just something you got to do. Then there's this custom animation that's really cool for the switches. We initially had just kind of a static state, but this was one of the places like, okay, we can do something more than just kind of your standard engineering sort of buttons and switches sort of interface, but we'll give it a little bit of life. So there's some really nice colors and some cool animations in there as well in this demo. Then this final demo is the motion demo we showed you. This is the trickiest one, and this took the most time because the 3D model's tricky to get right. The board's tricky to keep working early on when you're in that kind of prototype phase, early boards. But it was amazing how quickly this thing kind of came together. So a few of the challenges though, you see all of these labels on here, and those are all representing different pieces of data that have to be pushed over that low energy channel. And so there's a lot of data coming in, a lot more than you typically would expect from kind of a sensor. But it comes in really quickly, and it comes in a way that actually yields a really nice smooth demo. And then we decided it'd be really great to actually have 2 models, and they're oriented just slightly different, so their configuration is a little bit different. But You know, that's what we do, the software we deal with that. So then when you switch modes, as we showed earlier, you have this much nicer interface with the car actually there. The calibrate button, Jason was mentioning that's one of the places where we did some customization. There's a custom command you can send to the board to let them know, hey, you're in a stationary position, go ahead and calibrate all the sensors and get things reset. Again, that's what the board looks like with the kind of default mode. That's the mobile app. Then we have this cloud streaming piece. Now we demonstrated this inside iOS, and so you got to actually see the responsive front end. But there is a really nice kind of full desktop version if you look at this on a Mac or PC. We ended up choosing Firebase from Google. In hindsight, that was a really great choice. The real critical piece for us was how simple it was to get started. It was a really kind of pillar feature of this whole platform, was making things really easy to get folks kind of into this and on their way building something really cool. They have great native SDKs for Firebase, so that also helped too because it meant that we could go pretty quickly. We got a lot of kind of cool features along the way, so the Firebase SDKs on mobile actually have a store and forward capability, so we could actually just write data locally and trust that it would eventually get delivered to the cloud. So if there are connectivity issues that would delay that transmission, the SDK actually takes care of delivering that for us later on. It's something we got for free. And then if you've been following Google's news here in the last week at I/O, it's clear they've made a huge investment in Firebase as a platform going forward. So it ended up being a really great bet for us. What it also meant was that we could host a responsive front end in the same service. So we're not in the business of being an IT administrator. We're not running web servers and all that sort of stuff. We can set up an SSL certificate and be on our way. But what we end up with is a really nice set of real-time graphs that update while you're looking at them and actually live in a demo, and then great historical data after the fact. You see, this is kind of what it looks like on mobile. We got to see that a little bit earlier. Jason.
So in terms of obtaining the platform, we are, just like every other Kickstarter thing, we're this close to launching. And right now it's just building up the finished good kits. So I actually have 2 kits today that I'm going to hand out. But when you're in terms of obtaining the platform, it's going to be in mid-June. We'll do a big press release about this, and it'll be kicked off live on Silicon Labs' website. You can either get the little board, and so the board is $29, or you can get the whole car kit. And the way the car kit is set up, it's set up with the Pinewood Derby car mantra in mind. So the car is basically disassembled, and you get to assemble it yourself. So you get kind of a little bit of fun, and maybe if you have a child or if you're a child at heart, you'll really enjoy this. So the board's $29, the React car is $59. The firmware and the hardware collateral. So we have an IDE that Silicon Labs provide called Simplicity Studio. All this firmware is provided on that platform, as well as all the hardware collateral. So you just obtain the IDE and you automatically get all this information, all contained in one particular area. All you have to do is just type in the word Thunderboard in that IDE, and it'll populate everything that you need to get started. And then the way we have the firmware set up is kind of the same premise. You go hit software examples, and then you just basically import that over to your IDE software compiler, and then hit go, and then you can program and modify the firmware. One example that we didn't show later is I was trying to make a little balancing tilt detection type feedback, and it was really simple just to hack just a couple of lines of code in the accelerometer data that would interact with the LEDs with that, and just using Simplicity Studio to do that.
So in terms of obtaining the apps, these apps are actually live right now on the Play Store and on the App Store. So you can check out the detection screen if you download them tonight. And then once you're able to get these kits, you'll be able to just grab these off of either of the app stores. So I don't know if you caught it on that past slide. Jason mentioned about the availability of all the resources if you're interested in the hardware, but we're also going to open source both of these apps and the responsive web application as well. So all the things that we've shown here are going to be available either through the Silicon Labs website, or mobile apps will be on GitHub as well as the web application. So we thought we'd close it out here tonight with a little bit of fun. We've got a few things that as we've been kind of working on this project over the last few months, we've had a little bit of time to try a few cool things. So there's a few demo videos of some things that we've put together. Let you talk about this first.
Yeah. So one of the ideas that our firmware guide had was, let's change out the 3D model and put in the lunar module landing with it. So instead of a car, we have a lunar module, and we mounted a Thunderboard below it, so that as you move it around, it interacts with the app. So it's actually really easy to reskin the 3D model. If you have an OBJ file with the right origin, you can make this work pretty, within a couple of clicks.
And even if you don't have the right origin, we've got 2 examples now in there for you. The second one I hinted earlier about these racetracks. And so this is actually an Apple TV app that we have running at the Mutual Mobile office. We put this together for a hackathon. So this is a track selection screen and then car and driver selection, similar to Mario Kart, if you've played that before. And then once you're connected here, the app will actually connect to cars. There's a Christmas tree. The lights will go down the tree here. In the video, I'm actually walking over to the starting line. But you'll see the lights turn yellow and then green. The cars are running, and then you actually see the cars there at the end. Now what's kind of unique is there's actually an iPhone at the finish line, and in a second here it delivers high frame rate video back to the Apple TV, and then we'll play that in slow motion so you get a photo finish. Those 2 cars. And then if you've been following the news lately, Amazon's Alexa platform has gotten a lot of steam here lately, and I think Google and Apple are both poised to do really cool things in voice, but we thought it'd be fun to put together a demo with Alexa here, so I'm going to turn the sound up as loud as I can and let you see this.
Alexa, tell Thunderboard to turn the blue LED on. Alexa, tell Thunderboard to turn everything off.
So what you saw here, this is actually the only additions to make this possible to what you've seen here. There's actually an MQTT broker that I just used one of the publicly available ones. There's a Lambda function that runs the actual Alexa skill, and it's posting messages to an MQTT channel that the mobile app is then listening for. So it becomes a client to those channels, and it can receive commands and actually deliver status information too. What's really fun, I'm at a disadvantage because I worked on so much of this code, but this was a hack I put together in a couple hours one afternoon, just for fun. So, there's tons of opportunities for really cool stuff here, which is, I think, really exciting. So with that, we'll open it up for questions. Chris?
Jason, please tell us about the ARM microcontroller in terms of onboard memory, speed, and I/O.
Yeah. So one of the unique things that we have with, even though we're a new entrant to the Bluetooth market, this is actually a fully integrated Bluetooth radio and MCU. It's an M4 ARM MCU. I know we have 512 at the starting, and we're about to have a 1 meg version coming out here very soon. And the module, I believe, has 24 I/O, and we do have another module coming out that'll have 32 I/O. And if you do the chip down versions, they have up to 48, and I think 64 as well. No, 48. It ends at 48.
What speed does it run at?
I don't remember, but I can. You just got my card, so I'll send that to you.
Will the Thunderboard support BG script?
Yes, you can do it. I will say though, the MCU to be able to support that many sensors, I think we're at about 60–70% utilization on a 512 memory. The BG script is a little bit heavier, so you may have to make a little bit of sacrifices to make the BG script work for that.
And if you're releasing Simplicity Studio support anyway, we also support we also release the CSDK for the Blue Gecko at the same time.
Yeah, so this is in the CSDK. It's available now. It's the version 102 for this.
I clicked on it last night and it said 404 not found.
404 not found for the 102?
I clicked on the link for CSDK, download CSDK, and support.
Oh, okay. Yeah, I'll help you find it. That's kind of weird. So the other thing that's kind of, just real quick on that, our Scilabs has been doing this major responsive web page change, and there may be some dead links in there. I know it's in there because I just pulled it yesterday, so maybe we'll probably find the right link. I'm sorry. Hi.
What are the initial vertical markets you're going to focus on using this initially? Or is it just a generic,
Yeah, I think the obvious stuff is a lot of connected home. I think for stuff like this, especially Bluetooth, I think it's going to be a lot of products like I could talk about, like the DeWalt. Things where something like Zigbee doesn't quite make sense because it's not in the home. Wi-Fi is just too power hungry. So then everyone goes, well, I know Wi-Fi and Bluetooth, but the problem with Wi-Fi is built for data, and that's very power centric. So it's got to be something that just minimally burns the amount of power. So it's got to be something that you can link to Bluetooth. I know Caterpillar, for example, they built a connected tractor, but then what they did is they did kind of the OBD2 type interface, and then it's connected to your cellular out. That'd be like an application that you could potentially do for something like this.
What, if it's Bluetooth, what is the reliable maximum range or distance between the device and the
So I don't apologize, I don't remember the exact numbers, but it's either a 6 dB or 8 dB type range for the standard Bluetooth. We have Bluetooth modules that have the longer range capability, which I think does 20 dB capability to give you the longer kind of range. And I
what
apologize.
is that in distance?
Yeah, I know it with Zigbee. So like with Zigbee, with 8 dB, you can get 100 meters line of sight with that. Now Bluetooth, you can get that in one direction, but then you have to have another unit on the other end that's capable of talking back in the other direction. Hi.
So on the PCB, will a JTAG breakout section be available, or would JTAG be available at all at Cortex? Or are you guys disabling that?
I think in the Bluetooth module we don't have that capability, but in the chip down we do.
Are you disabling it, or is that enabled?
So we do support the Cortex tools for that. I believe it's enabled
Okay, cool.
for that. I saw one in the back. Hi.
Two questions. Have you tested with any long-range, low-power RF technologies, whether it be LoRa, Ingenue, or otherwise? And then secondly, can you plug in more memory? You talked about a stored forward SDK. If you want to store more memory, can you do it?
So you can add more memory with that. We do have like a roadmap of bigger memory devices coming out a little bit later. LoRa is one, like Silicon Labs is looking at. We don't have a product right now today. I know Sigfox is the other one that's out there. I think we're kind of experimenting with both and making a decision on, do we support both or do we focus on one or the other. I know LoRa is on our tactical roadmap plan right now.
But if we know the RF side is modular, so we can plug in our own.
You can do that, yeah. If you got that capability, you could technically do that. Definitely. I saw a hand. Hi.
Actually, two questions. The thing supports 6 low WPAN over BLE, the first one, and second, do you plan to support ARM embed OS platform?
So in the 6 low pan, we don't have that support right now. The embed, that's been kind of an interesting one. So there's actually another Thunderboard that was released earlier on. It's called the ThunderBoard-React, and it actually is a joint promotion with ARM. Embed is becoming a little bit more of a challenge than ARM was realizing, trying to get it out there. I don't want to get too much more into that, but it's delaying a little longer than I'm expecting. I think that's what I can say publicly. It's supposed to happen. We're one of the companies definitely supporting it, but I think like everybody else that comes out with a new standard, especially something unique like what Embed is trying to do, it's going to take a little bit of time. I always want to be honest with people. And that's why I'm not trying to be like doom and gloom, but it's one of those things that I think it should work, it will work, but they're trying to work through some different nuances with that. Yeah, so like an example for that you should definitely ask Thaddeus about was iOS and Android. So like for doing like the models with iOS, it took a matter of like a day or two to get a base example, but then with like Android, I'm asking you like, when are we going to see this Bluetooth, 3D module with Android? What happened there, Thaddeus?
So those Android folks are. No, I think that a a lot of the 3D stuff that you see on Android is done in C++. A lot of the games are written in C++. That's, you know, typically what a lot of games are written in anyway, to meet the demands of consoles and, you know, really have great portability. So this is primarily a Java app, but we did have some folks, and we brought in a couple of folks that were on other things, but could come in and really knock this out. And it's not necessarily fair to say that it was harder on Android. It just happened to be super easy on iOS because of SceneKit. So we happen to have something that Apple had provided, you know, just a year or two before that was really great and intended for making 3D look really easy. It's still pretty freaking hard. So we had an advantage there where we could do that fairly quickly. What we didn't have was kind of the breadth of support for the different models. So where Android could, you know, initially kind of decide, well, any of these will work, the OBJ file's fine. That wasn't necessarily the case early on. We've got newer models now that are actually the OBJ files too. So you see those, the textures on the circuit board, that's an OBJ file with textures loaded too. But yeah, it was tricky. It was something that we'd never done, and so that was, I think, I remember back to our first kind of discovery meeting. We're like, is this like a stretch goal? No, this isn't. We got to do this.
So you said the Apple Seed Kit?
SceneKit, yeah.
SC. Oh, sorry.
Yep,
Go ahead.
SceneKit. Yeah, so they've got a 2D library called SpriteKit for making 2D games, and then SceneKit for making 3D, you know, typically games, but we leveraged it here.
So one question, the other thing you should be asking Thaddeus about. So I've heard of AWS, I haven't heard of Firebase. So why not just do AWS? I mean, and that's actually what we challenged Thaddeus when we came, or his company. We want to do this on AWS, and we have a really tight schedule. Let's do AWS. Why can't we do that?
I think the big thing for us was the maintenance. Being in charge of setting up servers,